G'day everyone. So my name is James Makinson. I'm a postdoc at Western Sydney University, and today I'm going to be talking about Tetragonella in the top end, the foraging ecology, nesting behavior, and potential cryptic species of stingless bees in the Northern Territory. So I just want to say from the start, I'm not a taxonomist. This is a kind of new research area for me, so please bear with me. This is very early days in the project. My screen's frozen. There we go. Okay, so this work is being done as part of a Hort Innovation Grant studying stingless bees as potential managed pollinators of tropical crops in Australia. This grant is being led by James Cook at Western Sydney, who was chairing one of the other sessions today, so you may have been to some of the talks. And my role in the grant is to coordinate the tropical field projects on this grant. I'm in charge of two PhD students, Gaurav Singh, who's been focusing on mango pollination. Again, he presented earlier today, so some of you may have been there and heard that. And Claire Allison, who's looking at stingless bees in macadamia. As a bit of context for what we've been doing in 2021, I just talked about 2019 when we went up to the Northern Territory mango growing regions to look at what floral visitors were turning up to the crop. This is part of Gaurav Singh's PhD work that we collected in the data and field. So back in 2019, both in the Darwin and the Katherine growing regions, we were finding that stingless bees were the predominant floral visitors of the crop. So with that in mind, obviously we couldn't go anywhere in 2020 due to COVID, but in 2021, hot off the heels of that data, we wanted to look in more detail about, so Gaurav was focusing on crop questions about whether or not the stingless bee visitations are impacting fruit yield, and I won't steal his thunder there, and also how the pesticides are impacting stingless bee health. But during this time, I spent a lot of my time wandering around the bush around these farms, and I was interested in what stingless bee species are found around these farms in Darwin and Katherine growing regions, where they're nesting, whether they're actually visiting the mango crop. And in the Northern Territory region, there's currently only one Tetragonella bee species described to be present in this region. And so I wanted to see how far to the east and west of this growing region you could still find this one species, and whether or not it really is one species. So back in May, we got into the car and drove up to Darwin from Sydney, which is quite a long drive. I'd highly recommend it though, if you have the time, and started searching around the farms in the Darwin region. So I found 75 colonies in total around the Darwin mango growing region. And the majority of these bees colonies were of the species that is described in the region the only species currently described in the region, Tetragonella melipes. So 72 of these colonies were melipes. But I managed to, so here's a couple of photos of, there's a very large diversity in the nest entrances of these bees. Presumably we think it's in response to ants, which are one of their main predators at the hive entrance. Whenever you find a colony, you almost always find weaver ants attacking the bees. So it's definitely a distinct issue for these colonies. And now we found 3 colonies of a very distinct looking bee, which local beekeepers have been aware of for quite some time, but is still yet to be described. The local beekeepers call this bee the Northern Territory hawkinsii. It's in reference to an East Coast Tetragonella bee called Tetragonella hawkinsii. This bee shares a lot of the characteristics of that bee, behavioral and visually. And these were much harder to find in the environment. So in only 4% of the colonies that I found were of this species. Now, and here you can see one of the defining features of these stingless bee colonies is that they have a large number of guard bees, which spend all their time milling about the entrance of the colony. And it's not quite clear what they're doing there. I'll show you a video of what happens when you disturb the nest in a minute, and you'll see that they're actually quite cowardly guards. But so we've collected 20 workers from every colony that we've discovered, and we are planning to do a morphometric analysis But off the bat, just looking at these bees as we found them in the field, one of the clear defining features that you could distinguish between the Tetragonum melipus and this currently yet to be named NT Hawkinsii bee is the NT Hawkinsii has distinctly black eyes, whereas Tetragonum melipus has this bluey gray eyes. And that's quite clear when you see them in the flesh, but when you preserve them in ethanol, that distinction disappears. So it might be hard to use as a taxonomic marker for, say, museum specimens. And back in 2019, James Hereward, who I'm collaborating with on this project, has actually confirmed the species status of this second species. So it's visually distinct, but it also is distinctly a new species. But it's actually not very related to the Hawkinsii on the East Coast. It's more closely related to the Tetragonum melipus. And as I mentioned, they differ quite distinctly in terms of their behavior. And here's a nice little video of what happens when you stand in front of one of their colonies. So all the bees either shoot off into the air or run back into the hive. So if they are guards, they're definitely not guarding against large mammals like humans. They seem to be quite cowardly. But so as I said previously, my background is bee behavior. And so this kind of thing is really interesting to me, and would like to pursue looking at the behavioral differences in the future, but it's still early days. So we also wanted to know where are these bees nesting? So as I mentioned, in the growing region, I found 75 colonies. Here you can see the distribution of 50 of these colonies, which were adjacent to a single mango farm in Lamble's Lagoon. And one thing that immediately pops out is that there seems to be a clustering of colonies on the edge with the crop. And this isn't a bias of the search pattern. We thoroughly searched throughout this bush fragment. And we were finding colonies up to 460 meters from the crop in adjacent to the bushland. Yeah, predominantly we're finding them in ironwood trees, which is a very common tree in the Darwin region. And here you can see a very cryptic hive entrance sticking out of the bark of one of these ironwood trees. We're also finding them in Darwin woolly butts, which were again a very common tree species in this region. And so a number of these colonies had very large entrance tunnels, but it seemed to be quite variable. Previous people have suggested that entrance tunnels are built in response to predation. So it's a defense against, say, ants or small reptiles eating the workers. And so a small proportion of the workers were actually finding in man-made structures like poles or in the sides of buildings. And they seem to be really heat resistant. Some of these poles are out in the middle of the sun and heating up in the midday sun in Northern Territory, which can be scorching hot. So the thermal resistance of these bees must be very, very high, very tolerant. So as I mentioned, the majority, 75% of these colonies were found in the ironwood trees, and then a smaller proportion, 14%, were found in the Darwin woolly butts. And then 6 further colonies were found in a range of other man-made structures. So of these colonies that were found within 460 meters of the crop, are they actually contributing to pollination services on the crop? This is obviously an important question for us because we're looking at whether or not these bees could be a viable alternative to traditional pollinators such as the European honeybees. So here's just an example of one of the slides here. The large triangle is a eucalyptus pollen. These kind of ovoid pollens are the mango pollen that we were looking for. And so looking at all the, what I did is took swabs of the entrances of all these different colonies, and I found that mango pollen was present in all but 4 of these colonies. And even up to the furthest distance of 460 meters, the bees were still visiting the crop and collecting pollen. So clearly they are attracted to the mango crops, which is a great news from a managed pollinator perspective. So the final question that I had this year was, what is the range of this bee species? So it's one thing to show that it's really effective a pollinator in the mango, which is Gaurav has shown in his presentation today. But we also want to understand where they're naturally found. So in this trip, we sampled in 3 different locations. We went to the Darwin growing region, then we went out east, west to Keep River National Park, which is right on the border of Western Australia. And this is right next to the Kununurra mango growing region. So it's really important from a mango production perspective. And we were thinking that this may be a isolated population from the Darwin region because the landscape changes fundamentally in between these 2 regions. And so this is the field site that we were sampling in. This is a gorgeous national park. Again, I really recommend if you have some time to spend some time in the Northern Territory, absolutely stunning. One of the really characteristic things about this region are the large baobab trees, which you find all throughout the landscape. And so after over a number of days searching this national park, we found 14 different colonies. 10 were nesting in rock cave walls, 2 directly in the ground, and then 2 in these large baobab trees. So I'll just show you some pictures of the hive entrances. So this is a rock nesting bee colony. And they seem to be nesting in tiny sliver holes in the rock. So there's really not much space there. And what we're finding is within about 1 meter of each colony, you'd find large resin stalls stuck to the side of the rock. So often in other tetragonal bee species, they store the resin inside the hive, but it seems perhaps because of the cramped conditions of these colonies, they're actually storing the resin away from the hive itself. And here you can see my colleague, she's quite short, she's 150 centimeters, but she's standing next to this baobab tree, which is ginormous. And just by her waist, you can see there's a slit in the tree, and within that slit, there was a colony. And I've removed the picture, sorry. And here's another baobab tree which had fallen over, and at the base of the tree, I found another colony here. And finally, I found a number of colonies which were directly nesting into the ground as well, which so before doing the searching of this national park, I was talking to one of the rangers who is an Indigenous relations officer. And he was actually telling me about the traditional story about stingless bees in this region, that there are 3 types of bees in this particular national park. One in the rocks, one found in the trees, and one found in the ground. So just by chance, I literally stumbled over this stone, looked down, and I found one of these ground bees, which the Indigenous owners have been talking about being able to find. And here's the entrance of another ground nesting bee colony. So here's a close-up of one of this Keep River National Park tetragonal bees. Again, you can see the really distinct bluey gray eyes that you also see in the tetragonal melopus in the Darwin growing region. So at this stage, it's an open question whether or not we're just seeing diversity in nesting habitat for these bees, or whether or not we're seeing a distinct species. But I'm going to kind of steal my thunder a little bit here because, as I mentioned, I'm collaborating with James Herwood, and he's analyzed a single specimen that that was given to him by a member of the public from this region, and it appears to be distinct to the Darwin melopus again. So he feels, at least at this early stage, that it is a 3rd species, even though it does look quite similar to the one that we find in the Darwin region. So finally, after that, we went to the Limmen National Park, which is on the eastern border of the range. Again, we spent a number of days searching the landscape. This was upland rocky landscape, which was characterized by small patches of these large, amazing sandstone rocks jutting out of the ground. And again, we were finding bees nesting in the sandstone. So in this landscape, floristically, it was quite similar to the Darwin region. We're seeing a lot of Darwin woolly butts trees and a lot of ironbark trees, but we didn't find a single colony in these trees. We could only find colonies on the rock cave walls in this landscape. And here are just a couple of photos of the entrances. So there's, again, a huge variation in the entrance tunnels of these bees. And then if we look at a worker close up, again, it's looking like the Darwin melopus bee. But again, we're yet to do any kind of molecular work yet. So it's really an open question, are we seeing the eastern edge of the range of this bee, or are we seeing a different bee species? And here you can see just a snapshot of one of each of the distinct regional bees. So this is really early days. I just wanted to get the message out there that we've been doing this kind of work in the last trip. And hopefully by mid-2022, we'll have done some molecular work and morphological work to be able to say whether or not we are seeing diversity of nesting conditions or cryptic species. So that's about it for me. Thank you. If you have any questions, I'll be glad to answer them.
Thank you so much, James. I just love hearing people's field adventures and how they actually went about discovering what they found. So that was a really cool story. In the aspect of time, because it is 4 o'clock, we'll keep, or Adelaide time, we'll keep moving. But if you've got a question for James, I'm sure he'll be happy to answer it in the chat or catch up with him after the session.